And when it slows down, it changes wavelength. So what comes in as light, when it hit, by the time it hits the earth, it's absorbed and changed to heat. And some of that normally is reflected back out into space off of things like the shiny water and the ice caps and things of that sort. But if we get enough particles floating around in the atmosphere, as it bounces up, back out into space, it hits one of these, and then bounces back to Earth or the inside of your automobile or inside of that commercial greenhouse. So this is how that works. This whole greenhouse effect is based on, and see, in your car, this is a sheet of glass. That does the same thing. It gets in, as it goes through the glass, it slows down, changes, tries to radiate back out, but now it can't get through the glass, so it just bounces back like a mirror back inside your car, or in this case, back to the earth. So greenhouse gases can cause changes in the atmospheric temperature. Maybe minutely, but it doesn't take a whole lot. Some organisms have like a 2-degree temperature range that they can exist in. It's colder than that they die, if it gets hotter than that they die. Humans and other mammals have adapted by being able to keep our bodies at a certain temperature all the time. Reptiles and fish, for instance, though, can't do that. And so, very often reptiles and fish will go into a shutdown, where their bodies virtually stop functioning, but just enough to keep them physically alive. Some mammals can't do that, can't maintain that temperature throughout the winter, so what do? Hibernate. And so a bear will get real fat before, and see, that's what our bodies were designed to do, is get real fat before the bleak season. Unfortunately, we never have a bleak season food-wise, so we tend to store more than we will use. But biologically, that was a methodology, a mechanism for survival that we put on weight, and then if we hibernated, and our system's almost shut down to go into a deep sleep, but you gradually metabolize all that excess stored energy up until you wake up in the spring when you can maintain a body temperature a little more easily. But, all that being said, we have adapted different ways. Humans have gone a step further. How do we adapt to the environment? We change it, don't we? We make it to suit ourselves. So we're sitting here in a heated room with artificial lighting. And if this were a classroom a few centuries ago, we might be have a coal stove over in the corner trying to keep warm. The people in the back would be hot, and the people up front would be freezing to death. And kerosene, light lamps around, maybe. So we've come a long way, or depends on how you look at it, doesn't it? We've come a long way technologically and to make ourselves more comfortable. We've also come a long way into using up resources and unfortunately polluting the environment. Let's see. Well, I'll just mention it. The more reflective the Earth is, the more of that excess heat is radiated back into space. So what are the most reflective areas on Earth? What did we say?
Ocean and glaciers.
Ocean and ice formation. And sometimes oceans can have enough stuff in them, algae and particles and stuff, that they'll actually absorb quite a bit. But glaciers in particular and ice caps reflect a lot of the heat back out into space. Now, if the glaciers are melting, what does that do to the Earth's ability to reflect? It reduces it, and so we have a tendency to gain heat as a result of it. And that term albedo, that's used for that. Not to be confused with libido. That's a whole different word. Anyway. All right, these are, again, basically data that's gotten from NASA and all the weather satellites and so forth. If we have an excess of carbon dioxide building up in the atmosphere, it's got to go someplace. The oceans have moderated it for centuries. The CO2 goes in, dissolves into the oceans, and with the mass, the huge volume of water that oceans represent, it's kind of moderated the CO2 that stays in the atmosphere. But what we're finding now is that excess CO2 is going into the oceans to the extent that it's changing the biochemistry of the environments in the oceans. And we see coral reefs dying as a result of this. There's too much CO2, it dissolves the calcium that they use to make their homes out of, which we call the coral. The little animals are actually little jellyfish-like things, little tiny things, have tentacles and everything. And if you scrape yourself on coral, you can get quite a nasty abrasion because those little jellyfish are hacked off and they're squirting their little venom and stinging stuff right into that open area that you scrape. So I've had first-hand experience with that, so I know all about it.
Is that why they're turning white when you're talking about bleaching and
It's actually destructive to the animals that create it. So we've seen two things happen. Sea level is going up. It's documented. There are certain talk radio hosts that will tell you it's all a bunch of hooey, but it's hard to argue with data. The reason behind why it's happening is the arguable part, not the fact that it's happening. So, if the melting glaciers and so forth are going on, we're adding water to the ocean, which raises the sea level. Ice is a lot less dense than water, that's why it floats. So much of our floating ice keeps the water up into the atmosphere, so to speak. But as it melts, turns into water, and again, the retreating of the glaciers is doing the same type of thing. Every time you see a glacier, you see a stream coming off of it, or you see it directly going into an ocean. And we got to see all kinds of those examples when we were up in Alaska, two summers ago. Some of them are right on the edge of the ocean, or a bay or an inlet, and would just drop off into the water. The ones that were up on the mountains created streams that flowed down to the lakes and oceans and bigger streams and so forth. But eventually all that water ends up in the ocean. How much of the ocean water is usable to us directly? None of it. What percentage of the total water on Earth does it represent? 97, 98%. So if we increase the oceans, we're actually decreasing the amount of fresh water that's available. The other thing is thermal expansion. When a substance gets warmer, its molecules are vibrating more, it's got more energy in it, and it causes them to actually expand. So, all of you have probably opened a canning jar that's, you can't get the top off, so you stick the cap under hot water for a few seconds. You can tell you right off, that cap expands more than the glass does, so that loosens it up. But we have, anytime you have expansion, that's going to make the volume of water even bigger. So we have adding water through the melting process, and we have expansion through the actual warming process. Okay, well, all of this is a vicious cycle in some ways. Again, I think they're natural cycles. I think there's been thaws and freezes in the whole history of the Earth. You go out and look at fossils, and you see fossils of something that might look like palm leaves.